morning, friends. Myself, Dr.M.H.Annaiah, Vice Principal at Saptagiri College of Engineering and former Principal at Dr. Shivkumar Mahaswamy College of Engineering, Bangalore. A hearty welcome to this session. Friends, in today's session, we are going to have a problem on the development of a hexagonal pyramid which is cut by a section plane which is normal to HP and inclined to VP. So let us see what the problem is in store. It says a hexagonal pyramid having side of which 30 mm and axis 60 mm resting on its base. So the hexagonal pyramid having the base A, B, C, D, E, F, and the height of the solid is equal to 60 mm measured from O, the vertex, till the center of the bottom face O1 is cut by a section plane. So before that, let us see how to place the object, the pyramid, on HP and obtain the top and front views. That is the first part of the question. He says it is resting on its base on HP such that one of the shorter edges is parallel to VP. I will take this AB as one of the shorter edge parallel to VP. VP is that board. And get the top view and front view. The top view is going to be a regular hexagon with the vertex O joined to all the corners. And in the top view you get the hexagon. In the front view you have 1, 2, 3 triangles you get. OAB, OBC, etc. 3 triangles. Or you will be able to see 1, 2, 3, 4 slant edges along with this part of the solid. So let me complete the projections of the solid first. This is X line. I will be marking VP by HP indicating first angle projections. Let me complete the top view of the solid. Top view is a regular hexagon. And the side of each is equal to 30 mm, that is specified in the question. This dimension is 30 mm. Let me mark it as A, B, C, D, B, C, D, E, here. And let's locate the center of the solid, that is O, O1. Join all the corners to the center. So this is O, O1, where O is the vertex and O1 is the center of the base. And we have this A, B, C, D, E, F, the base. So here all these slant edges are visible, and this is the top view of the hexagonal pyramid with one of the base edges BC or EF parallel to VP. And here let's obtain the corresponding front view. So from here we will just erect lines like this, project them and get the mark the center. From here I am going to mark the axis of the solid whose height is given to be 60 mm. This comes exactly in the center like this. So this point is A dash, this is B dash, F dash, this is B dash, F dash, this is C dash, E dash, this I will mark here, C dash, E dash, center of the bottom face is O1 dash, this is D dash. So let me join this vertex O dash to all the corners of the base. Join O dash A dash, O dash D dash, O dash C dash, O dash E dash. So I just join the vertex of the solid to all the corners, and this is the base of the solid A, B, C, D, E, F. Let me mark the height of the solid, that is given to be 60 mm. So the friends, I have completed the first part of the question, that is obtaining the projections of the solid, that is the top and front views of the solid. Now, without any section plane cutting the solid, we will have the development. As you know, I am going to obtain first of all the true length of the slant edge, and then get the development without the section plane, wherein we will have 6 triangular faces, and all these triangular faces are isosceles. And before that, we need to have the true length of the slant edge. And if you observe the front and top views of the solid, you find that OD, one of the slant edges of the pyramid, is parallel to VP, and hence O dash D dash will give you the true length of the slant edge, and I mark this as R. R is nothing but the true length of the slant edge of the pyramid. So using this length R, I am going to draw here the development of the solid without any section plane cutting the solid. So this is what you are going to have. This is center O, that is vertex. This length is R. This length is also R. Taking O as center, R as radius. R is nothing but the true length of the solid, true length of the slant edge. This is R is equal to true length. So I have drawn this. Now friends, after obtaining the top and front views and getting the sector wherein you are going to mark all the 6 lateral surfaces as this. So remember friends, all these are same. All these will have the same dimensions. So here, all the base edges will be straight. I will just marking this by straight edges, because all the pyramids will have these straight edges for the base. So simply have drawn like this from all this. Remember, all these edges are of length 30 mm. The edges of the base 30 each. 30, 30, 30, all are equal. Friends, now let me mark the section plane. The section plane is cut by section which is normal to HP. So whenever the section plane is normal to HP in any orientation, it is seen as a line in the top view. That is, if you take this as a section plane, you keep it here like this, it is perpendicular to HP, you see in the top view a line. Like this, perpendicular to HP, you see it as a line. So you can generalize, that is, whenever the section plane is normal to HP, it is seen as a line in the top view. And also he says, the section plane is cutting the solid at a distance of 15 millimeter, and this is parallel to one of the slant edges. So 2 conditions he has given. It has to cut the solid at a distance of 15 mm, and it should be parallel to one of the slant edges. So suppose if you are keeping like this, at a distance of 15 millimeter from there, so this what will be the angle? It has to be parallel to OF and OC. So I am going to draw a line, the section plane, parallel to this OF or parallel to this OC at a distance, perpendicular distance of 15 millimeter, and see where all the section plane is cutting the solid. So let me take a distance of 15 millimeter from this slant edge, OF or this, and mark a section plane parallel to that and at a distance of 15 mm. So I am marking this at a distance of 15 mm. So I will call this section plane as SS. SS is the section plane that is cutting the solid at a vertical distance of 15 mm 1 pi from the vertex. Vertex is O here. From here I have taken 15 mm. That is 10. These two are parallel to each other. That is, the section plane SS is parallel to OF, one of the slant edge. Our section plane SS is parallel to one of the slant edge. So now, for the purpose of drawing, let us see what is the portion to be retained. He says, draw the development of the lateral surface of the larger part. So after the section plane cuts the solid, let us mark the points where the section plane is cutting the solid. So the base edge AF is cut here, slant edge OA is cut here, and the slant edge OB is cut here. Then the last slant edge BC is cut here. Friends, the whole of the pyramid is cut only at 4 points. 2 points for the base edges AF and BC, and 2 points this and this for the slant edges OA and OB. So in the development total you are going to have 4 points. Friends, you can also observe here, after marking this, the part, smaller part, this part I am going to throw away from SS this much, and the remaining part I am going to retain. So the part that is retained will be shown like this. This is the part that is retained. And so what I have shown here in color is the part that is retained. I mark this portion as P. P is the part that is retained for the purpose of drawing the development, and this part is removed. And this section plane is parallel to this slant edge. So we have done the major part of the development. We have located the points where the section plane is cutting the slant edges and the base edges of the solid. And now friends, it is time to start with the development here. So if you observe the portion that is retained, friends, none of the slant edges of the pyramid are totally removed when the section plane cuts the solid, and hence we can have the development of the solid starting from OA, the edge OA or OB or OC, whatever it may be. So let me start with A. So this is A, B, this AB is 30, C, D, E, F and A. So you have got all these, and now let us take one by one. If I am commencing from this point on AF, the solid is being cut by the section plane at this point. So this is a true length AF, which is equal to 30 mm. We can take the distance from A on AF and the base edges. AF, this much distance you should take AF. So I will say this point is here. This is again 30, you should remember. The midpoint of that is that. Next, when you come to the shorter edge, that is BC, it is cut here. I am very sure these two distances will be same. From C on CB, from C on CB, yeah, this is the point where BC of the base edge is cut by the section plane. So friends, we have the 2 points for that. Then let's come to the slant edges where the section plane is cutting the solid. So OA, the slant edge OA is cut here. OA is cut here. So here in the front view, we have this OA here. So project this line from there, and this is where the object is cutting the slant edge OA, that is O dash A dash. Friends, you can see here, this OA is the true length because this is parallel to VP. This line represents true length as well as this line also represents true length because both the slant edges OA and OD are parallel to VP. So you can take this measurement where the solid is cutting the slant edge on OA, this much on OA. So I will mark this distance OA and this is an OA. Remember, this OA is the same OA we have marked. Then the slanted OB is cut here. So let us take a point from there and move up to that OB line. So from here, somewhere here it cuts. So remember friends, OB, OF, they are inclined and then they are not a true length. Hence the point where the solid is edge is cut is to be transferred to the true length line. Suppose say I am transferring here the true length line. So, and I take this measurement on OB. I have to take that line. OB means what? This distance. The distance measured on the true length line from O is to be marked here. Friends, as I told you, we have 4 points, 2 on the base edges and 2 on the slant edges. And all the points so obtained are to be joined by dark lines or visible lines. So I am going to join this. This is one point, and here this I am going to join here, and OB is also cut here. So friends, after this the base edges are going to be joined here. These base edges. Now before I join here, tell you friends, the base edge EF, ED, CB are all intact. Or before that, if you start from the vertex, the slant edge OC, OD, OE, OF. OC, this is OC. OC, OD, OE, OF, they are all intact, and the base edges EF, BE, all these are retained. And friends, here portion from O to A, this part is removed. This is removed. And here on AB, AB is intact. The portion AB is there. On OB, some portion is removed. OB, you have some portion removed at the bottom. So this I will show you the thin line. And the last R is here, and on OA up to that is available. So this is intact, this is also intact. Friends, I have shown all the part that is remaining after the section plane cut the solid parallel to one of these. Friends, if you mark this as 1, 2, 3, 4, let me mark them. This is 1, 2, 3, 4, and this is say 1. These are all the points where the section plane is cutting the solid, and you can see very well here only a small portion of this, that is this portion AB, is removed. So when AB is removed, we will not have this line here, and you will have only a thin line, a thin line. So you will not have this, simply will show by a very thin line. And because the portion below this is removed, OB and OF. OF also you can see here. OF. OF is full, that's right. So this will give you the complete projection, that is development, and mark it as the development of P. Development of P, that is the portion of the solid, that is the larger part of the lateral surface of the pyramid. Friends, I hope this session was interesting And if you find this interesting, do subscribe without fail. Share the information with all your friends. Thank you. Have a wonderful day.